Yep.
So then you
Okay, let's look at number 11. Number 11.
So when we do that, are we dividing by ln3?
Yep.
Okay.
Yep, we're dividing by ln3. Okay, so 49 to the 5x plus 2. 49 to the 5x plus 2. Or it might be minus 2, what did I say? No, it's plus 2. 1/7, 11 minus x. Okay, this one, well, again, you want to try to make the bases the same. You want to make them the same if possible. We didn't back here because you can't make a 3 into a 7 by having a power. But when you look at some of these numbers here, these bases, 49 and 1/7, can I rewrite those to make them similar or eventually the same? And when you see a 49, you think of a base and a power to get 49? I know your times tables on this one. 7 what? 7 squared. Now, is that going to get us along the right way, you think? I mean, look over here. Is that getting us along the right path? Yeah, why? What do you see over there? You see a 7, you see a 1/7. So it's not the same, but it's getting there. So let's put down 7 squared to the 5x plus 2. Now, this is not 7, it's 1/7. Give you a clue. That 7 is to the first power on bottom. What can I do with that 7 to the first on bottom? Move it
On
to the top, becomes 7 to the what?
Negative.
Negative first. To the 11 minus x. You think that's a good strategy? Yeah. Why? 2 words. What do we now have? Same bases. They're both 7s. Okay? Same bases. So, let's take our powers to our powers. So we times them. 7 to the 2 times 5x is 10x. 2 times 2 is 4. Over here, 7, negative 1 times 11 is negative 11. Negative 1 times negative x is positive x. Now it's just like the very first question we did. If possible, make the bases the same. So I'm going to ignore these bases now. Now they're the same. Put down 10x plus 4 equals negative 11 plus x. I like to take care of the x's first. I'm going to subtract x to each side. 10x minus an x is 9x plus 4 is negative 11. Subtract 4 to each side. 9x is negative 11 minus 4 more, that's negative 15. Last thing we do is divide by 9. And you can simplify 15 ninths. 3 goes in here 5 times, 3 goes into 9 3 times. So negative 5/3. Okay. Number 13. Give us number 13. 7 to the 5x is 12. 7 to the 5x equals 12. Okay? And again, don't lose sight of what we're doing here. We're just solving equations just like you've done for the last 5 or 6 years. They're just getting more and more complicated. Okay? You're getting smarter. They get more complicated. Everything balances out. Okay? So can I make my bases the same? I mean, when you have a base of 7, could I rewrite 12?
No.
7 to some power? No. If that was a 49, we say it's 7 squared, but it's not. There's no way you can rewrite 12 as 7 to some power. So we need to take the log of each side. So again, I'll just watch right here, okay? All you do is this. You write down the problem, and then all you do is slip in a natural log here and here. Go ahead and do that.
Does it matter if you do natural log or just common?
Common log's fine also, okay? Could you do a log base 4? Sure. I'm not gonna though, because where's the log base 4 button on your calculator?
Nowhere.
There isn't one. You either gotta do common log or natural. It's gotta be one of the two. Okay? Then think back to question number 9. Once I take the log of each side, what do I do with that exponent?
Move it to the front.
Move it to the front. So I'll write down 5x times natural log of 7 equals natural log of 12. Now we're going to try to finish this out in one shot here, okay? I want to get x by itself. I need to get rid of what, Jordan? Keep looking. Just that?
X.
Not the x. I want to get x by itself. And the 5. Now what does 5x ln 7 mean? 5 plus x plus ln 7?
5.
5 times x times ln 7. So let's do it all in one shot. To get rid of that 5, divide by 5. Divide by ln 7. Divide by ln 7. Let's do it in one shot. Just divide by what? 5 ln 7.
You can do that?
Sure. So we type in the natural log of 12 equals, divided by 5 times natural log of 7 equals. And I'm going to tell you what the answer is, but again, you got to know how to type this on a calculator. The approximate answer is 0.255. And again, the only way you can figure that out is using a calculator. I didn't use a calculator because I'm looking for the answers. I had no idea what the answer was. Okay, you'd have to use a calculator or something like that. So about 0.255. Okay, number 15. Solve 3e to the 4x plus 9. 4x and then plus 9. I think that's what it's saying. Where are we at? Plus 9 equals 15. Okay, I've asked this question before. I'm going to ask it again, see if you guys still remember this. What are we solving for? Are we solving for the variable x or the variable e?
He's not a variable.
E is not a variable. We're solving for x. E is not a variable. It's what? It's the number approximately 2.71. It's roughly 2.71. E is not a variable. Okay? So we want to get x by itself. And it's not that you did this back in middle school. I mean, you did, but not problems that look like this. Our first two steps are really, really easy, though. You learned them back in middle school. What's the first step? It's a real simple step. Minus 9. Minus 9. So we have 3e to the 4x equals 6. Next step, this is not much harder. Divide by 3. You knew that before. Divide 3, divide 3. So I'll put this up here. I have e to the 4x equals 2. Okay. All right, so here's what we need to do, bless you. Okay, here's what we need to do. Well, I mean, can I rewrite? I mean, we can't make our bases the same. That's a 2 and that's e. I mean, there's no way you're going to make those bases look the same. Okay, so we take the log of each side. Okay, so slip in a natural log, slip in a natural log. Then what? We've done it 3 or 4 times today already. Move the 4x out front. Okay. Now something I've not shown you, we're going to put this question on hold for a second here. Okay. No calculators. I won't using a calculator right now, okay? What is the natural log of e? And don't say, oh, it's this. What's that? Well, what is it? That's an actual number. I mean, for example, this is a number. Hopefully you guys haven't forgotten this. That's the number what? What's the log base 2 of 8? Don't say 4. 3. Why? 2 to the power of 3 is 8. Okay? How about this one? As long as you remember the shortcut, this is a simple one. What's the log of 100,000? 5. Because what base is it? You don't see it. It's a what though? 10. How'd you guys get 5 so quickly? 5 zeros. 10 to the 5th is 100,000. Also 5 zeros. Okay? Natural log of e. Here's the long way.
What is e the natural log?
Well, here's what it is. I could rewrite this. This is the log base what?
E.
So the log base e of e. What's the log base e? So again, natural log is the same as log base e. Huh?
It's 1.
Why? Don't say times. Why?
I didn't say it.
Oh, who said it? I heard somebody say 1. Well, I'm sorry, ladies.
Me and...
Why is it 1? And don't say times. E to the first power is e. Good. This is the number 1. The natural log of e is 1. Because e to the first is e. Okay? So, what's 4x times natural log of e? 4x. Because it's 4x times what? 1, which is 4x. That's the last thing we have to do. Divide by what? 4.
Natural log.
Oh, no, we want to get x by itself. Divide by 4. So the natural log of 2, whatever that is, equals, divide by 4. The exact answer is the natural log of 2, divide by 4. And be careful here. Some students say, well, can't we just do the natural log of a half? They think, well, 2/4 is a half, okay? This is not saying the natural log of 2/4. It's saying the natural log of 2, all of that divided by 4, okay? It's not the same thing. If you type that in, you punch them in there, IOB, see what you get. So just type in ln2 equals, and on the calculators you type in ln first. The natural log button's the upper left-hand corner. Whatever that equals, then divide by 4. 3 decimal places, and they give you what? 0.173. Did you type stuff in on your phone last time we did these? Or not?
No, it was my computer.
Your computer?
But I
Is it
think
easier on that?
I think it was the same thing.
But, okay. I'm going to tell you right now, not to knock cell phones, but it's trust me, it's a whole lot easier typing it on a calculator than it is on cell phones. Okay? Is that a new thing? They have calculators on those cell phones? I've had this for a while.
We've had that.
Really? They're going to have pictures on there. You can take pictures of those pretty soon, I bet. Okay. It's a joke, haha. 21. Okay. Let's do an easy one. Let's do an easy one. And I'm going to say something you're not going to see in a math book. It's not really mathematically accurate, but oh well. It'll get the job done. Okay? ln of 4x minus 7 equals, you guys are going to like this one. This is not sarcasm. ln x plus 11. Now, before we actually do this, Iobi's going to help me out here because she's got the calculator. All right. Do me a favor. Okay, I want you to type this in. You tell me the answer. Okay. Tell me give me the natural log.
Just natural log.
Yeah. What's the natural log? Let's back up here. Tell me the square root. Very good. What'd you say? Of what? Okay. So when I say give me the natural log, your response should be of what? Okay. I didn't tell you. Okay. Or it's kind of like saying, I want you to add the number. Add this up for me. Add up 7.
What?
And okay. So what I want to make sure you understand is this. Okay. This is not mathematically right. Okay. We have a natural log here and a natural log here. Okay. If you have just like we added on the natural logs, we plug those in. You know what else you can do? You take them out. Okay. We're not like dividing by natural. They're just getting rid of them. Okay. So what am I going to write?
4x minus 7 equals x plus 11.
You know how to solve that? You better. Okay. You've done that problem 1,000 times in the past. Yes, ma'am.
Okay, so this may not be right, but since okay, so like the bases are the same, can you just do that?
Can you what?
I don't know if that's what you just said, but
Well, what we're saying is this. Just like we added in the natural logs, you can take them away.
oh okay.
They're both there. What did I do? I just erased them. We didn't divide by natural logs. That doesn't really make sense.
So if there was like a number there, would you just?
If it was a log base 4 and a log base 4, they both go away.
Oh.
So, now hang on. Log base 4 and log base 12, they don't get to go away. Or common log, natural log, no. Those are quite a bit harder. Don't worry about those right now, okay? So, all right, so then we subtract x. 3x minus 7 is 11. Add 7. 3x is 18. Divide by 3. X is 6. Okay? Now, here's the deal. You're still up, okay? What's the log, natural log, of negative 7?
There.
What's the common log of negative 12? Error. I knew that was the answer both times, okay? Something we have not talked about, okay? If I give you this right here, okay? I asked him what I think said the log of, we'll say negative 10. What's the log of negative 10? Okay? Something we've not talked about yet. We're talking about it right now, okay? If he types it in, I know what it's going to say. It's going to say error. Here's why, okay? My base right here is 10, okay? If I wrote this without logs, it'd be 10 to some power equals negative 10. You might be tempted to say the answer is negative 1. No, it's not. 10 to the negative 1 is not negative 10, it's 1 over 10, okay? Just watch right here. What the heck does 10 to the x look like? If I give you y equals 10 to the x, that's exponential growth because 10 is bigger than 1. Be growth. Remember these curves? When does this get down to the x-axis? Never. Therefore, when does it get below the x-axis?
Never.
So when does it get to be negative? Never. You can't take the log of a negative. You can't. Because it never even gets to 0, let alone negative. Okay? I don't care what number you type in that's negative. You take the log of any number, you're going to get a negative, okay? So, or you're going to get an error. Take the log of any negative number, you're going to get an error, okay? So, what I'm bringing it up for is this. You need to check your answers, okay? I'm looking for a 2-word response right here, okay? Hopefully somebody gets it. I've already said it. Let's see if you guys catch it. Looking for a 2-word response. Is 6 okay? If I plug in 6, 4 times 6, take away 7, will that be okay? Well, 4 times 6 is 24. 24 minus 7 is 17. Is that okay?
Yep.
Why? What's the 2 words I'm looking for? It's
Not
not negative. If you get an answer, you plug it in. Let's just say we did all our work. We did all our work, and we got an answer of x equals negative 10. 4 times negative 10 is negative 40. Negative 40 minus 7 is negative 47. What's the log of negative 47? You can't, okay? What I'm getting at is this. If I give you this right here, let's use natural logs. Is that a true statement? We could have an argument on this one. I mean, it kind of is, because what's 4 minus 7? Negative 3. Is the natural log of negative 3 equal to the natural log of negative 3?
But you can't get the negative.
Well, it's kind of like saying this. The number of pounds old I am equals the number of years that I read last night.
What did you just?
Is that kind of true? Because the numbers don't exist. I mean, yeah, does this look like, isn't it 4 minus 7, negative 3? I mean, they look very, is this a true statement?
Yeah.
They look the same, but this number doesn't, how many pounds old am I? That number doesn't exist, okay? It doesn't exist. How about, okay, we'll use this. We'll use the Bigelow kids, okay? Cal and Max Bigelow. Is the number of pounds old Cal equals the same as number of pounds old Max equals?
No.
You can't really answer that. I mean, are they the same age?
Yeah.
So what's wrong with what I'm saying? The number I'm asking for doesn't exist. You can't count how old somebody is in pounds. That doesn't make sense, okay? So what I'm getting at, let's make this real simple. If you take the log of a negative, it doesn't exist, okay? Let's try maybe one more question. 23, yeah, one more. Just one more for today. But you got to check your answers when you're taking the logs here, okay? All right, Jordan, this one's yours. Log base 3 of 3x minus 4. Or wait, log base 2. Log base 2. Log base 2, 3x minus 4 equals the log base 2 of 5. Okay? What can I do?
3x minus 4 equals 5.
What'd you do? You're right.
Took out the log.
You could do that?
Yeah.
Because the bases,
Same.
and if they're not, you can't. But don't worry about that. So just write down 3x minus 4 equals 5. Add 4, add 4. 3x is 4 plus 5, which is 9. Divide 3, x equals 9 divided by 3, which is 3. We're not done. Think back to the last problem. We got to do one more thing. Check it. Is 3 okay?
Yes.
Because 3 times 3 minus 4 is a positive number. Okay? It's a positive number. Actually, I'll tell you what.
So how come we didn't check it for like 11?
Which one was 11?
It was negative 5.
In all honesty, here's the deal. Way back in Algebra 1, Mrs. Thomas, or whoever your teacher was, should have told you, and I'm guilty of this too. You know what problems you really should check? All of them. You really should check all of them, okay? We're confident we're good on them. It's when you start off with the log on each side, you really need to check them, okay? All right, so this is the getting into these types of problems. There's stuff we haven't learned yet. We'll do that starting Thursday. So what I would really like you to do, and some of you guys, I'll give you guys a little bit of a lecture here, okay? Some of you guys are still on the mindset, oh, Wednesday, that's free day, okay? You have an assignment tomorrow, okay? What do you think it is? The evens. Fill in the evens that we skipped. I mean, you really need to do that, okay? I'm expecting you to do the evens, and we're going to continue on from then. Come to me with questions on Thursday. Don't wait till the day of a test. Go, I don't know what. If you ask me on test day, what's a logarithm? I'll be like, good luck.
Is it test on Friday?
No, but I'm just saying, don't get to that point, okay? So, I mean, do the ones that we skipped over tomorrow, and then if you have questions, ask me on Thursday, okay? All right, rest of the time's yours, guys.